Hello everyone, welcome back to the channel. In this project, I'm going to do clustering of movies based on their genres. There will be two types of clustering done in this project, which are hierarchical and k-means clustering. The data is manually collected from IMDB or Internet Movie Database website. So let's begin. Before we begin our cluster analysis, the first thing that we need to do is to load the libraries that we will be using in our analysis. So the first library is the TM library. To create the corpus, we're going to put all the movies genre names of those movies inside a corpus. So we're going to use the corpus function from this TM package right here. The next library is the tidyverse library. If you recall, the tidyverse library, the tidyverse here is contains a set of packages that we can use to play around with our data for data manipulation and also for data visualization. We're mainly going to use those two packages, such as perhaps the dplyr package and also the ggplot2 package for data visualization. And then we're going to use a library called factoextra. This library contains all the functions that we're going to use for clustering our documents. And just to be safe, we're going to load other libraries involving clustering as well, such as FPC and also cluster. Now we're going to import our data. For this, we're going to use the read.csv function, and the data that we're going to use is a CSV file containing all the information about movies, and the information is gathered from the IMDB webpage. So this dataset is actually in my workspace. It is located in a folder in desktop. So I saved the CSV file here in this folder called video project and cluster analysis, and this is the CSV file that we will be using in our analysis. To do that, I'm going to copy this the location of that file, and to do that, make sure that you have double backslashes in this read.csv function and the name of that CSV file as well. And we're going to save this in data frame called movies.tf. First, let's run this library package here first. And then we're going to import our data, and just let's try to take a look at the first few rows of our data right here. So the data contains few columns, which are title, which is the title of the movie. Other title here refers to if the movie has any other titles than the one that is listed in the IMDb page. An example that I can give is the title of some Korean movies that are listed in this CSV file. And the title would be the English version of that title, while the other title right here will contain the original title of that movie written in the Korean language. And the third column here is genre, the genre of the movie. And the next column is director, the film's directors. And next is the year that the film were released in. And then there is one column containing the names of the actors in that movie. And lastly is the full, not the full, but the synopsis, or like, you know, like the blurb of that movie, the what do you call it, the summary of that movie based on what is written in IMDB. So now that we have our dataset loaded in our workspace, we're now going to put them inside a corpus, and we're going to use this corpus function from TM, and the source is going to be a vector, and it is from our movies data frame of the genre column. And we're going to save this inside a variable called corpus. And let's try to look at one of the documents located, one of the documents that has been put inside this corpus right here. For that, we're using this writeLines function, and we're going to convert the, let's say, the 20th film, the film that has been listed as the 20th observation inside our corpus right here, and we're going to convert it as a character and use the writeLines function. And you can see that the 20th film inside our CSV file, our original data frame here, has the genre of drama and thriller. So then we're going to do some pre-processing on our on our corpus. First is to transform it to lowercase, and we're going to save this back inside our corpus variable right here. And to transform this into lowercase, we're using this tm_map function on corpus, and then there's going to be this function content transformer to transform all the sentences inside, let's say all the sentence inside the corpus into lowercase. Next is to remove the punctuation. The function is remove punctuation right here. And then we're going to remove any stop words. I'm not sure if, well, I'm not sure, but perhaps we can tell that there might not be any stop words inside our corpus right here. But, you know, just to be safe, we're going to just include this function as well. And the stop words is in the English language. And then we're going to remove extra white spaces. And lastly, we're going to stem the words inside our corpus. Sorry, I forgot to run this one first. Okay, so as you can see from this console right here, they came out with a warning message. It's nothing to be worried about, but it's just telling us that there will be some documents that will be dropped from the final corpus. So I think that there's not going to be any much of a problem later on. And now that we have completed our pre-processing steps, we're going to put all the words, all the the terms inside our corpus right here into a document term matrix. We'll save this into this variable called DTM. And we're going to rename the row names or the index names of our document matrix here to the titles of the movies corresponding to each of the documents. Okay, we're going to run this too, and now we have our document term matrix, we can proceed with the first type of clustering, which is the hierarchical clustering. So if we take a look at the number of movies that were listed inside our data frame, we see that there are more than 1,000 movies. Specifically, it's 1,453 movies. And if we want to display like all the clustering of that movie, the plot is probably not going to look as as clean or as clear as we want it to be. So for this, we're going to randomly select 20 movies from our data frame, and to make sure that we have the same results, let's set the seed to, let's say, 1, 2, 3 right here, and we'll randomly select the samples from our data frame using this sample function from the number of rows inside our movies data frame right here. We're only going to select 20 of those movies. We're going to make sure that there will be no replacements inside our sampling right here, and we're going to select those movies from our document term matrix using the sample size values right here, meaning that we're going to get the indices of the movies in our document term matrix. So we're going to do this by going through it like this. This function, this line of code right here will not randomly, but meaning that we will collect the movie titles and also the movie genre based on the indices that we have gathered using this sample function previously. And just even though that it's already in the matrix form, we just want to be safe. As a safety measure, we're going to just convert it into a matrix using this s.matrix function. And now we're going to do this hierarchical clustering, but before that, we're going to compute the distance between vectors. Perhaps if you don't know, the clustering is done by calculating the shortest distance. We see the shortest distance between any 2 points, and anyone with like the closer the distance between them, the more they are being grouped into one cluster. I hope it makes sense to some of you who are not familiar with clustering. So therefore, we're going to calculate the distance between the document vectors that we have in our DTM matrix here. We'll use this distance function on our M20 matrix that we created earlier right here, over here. And let's save this inside like a simple variable called D. And now we're going to run the hierarchical clustering hclust using the distances that we have calculated earlier, and the method of our clustering right here is word D, and we'll save this inside a variable called groups. And to see these movies, the movies that have been clustered together, we're going to plot a dendrogram using the groups variable that we have created earlier. And this argument right here, hang equals to -1, is to make sure that the labels or the names of those movies would be below the tree. I think I can, let's try not to include this argument first. So as you can see, if I zoom this plot right here, if we don't include the hang equals to -1, it will be yeah, you can see that it is not like in the same level here. But if we include this one right here, it will be display on the same level. Like you can tell like the difference between the earlier plot, right? So here, now that we include that argument of hang equals to -1, the movies of this dendrogram is displayed like in a, like, let's say we call it like a cleaner manner. We can see it more clearly, the movies that have been grouped together, clustered together. We can see, like, for example, here the animation film Meet the Robinsons and Despicable Me 2 are clustered together, so it's fine. And for these two movies right here, The Matchbreaker and My Little Bride. My Little Bride is actually a Korean movie, and The Matchbreaker is, if I'm not mistaken, is a Hollywood movie. I believe that they're both in the genre of romantic comedies. So I guess, yeah, you could say that it makes sense for them to be grouped together here as well. As for this one right here, Arrival is the sci-fi film, the one starring Amy Adams. And then the Night Stalker is the fiction. I'm not remember if it's like it tells the story about the Night Stalker, a true crime that happened in the United States. I think in the United States back in the late 60s and early 70s. So I'm not sure why they grouped together, but perhaps maybe it's because the genre is similar, I think, or maybe not. But yeah, I think it's normal. Usually it's normal for our analysis to have like this, these false positives. Now that we have looked into hierarchical clustering, let's proceed to k-means clustering. So as I mentioned, the data is a list of movies where the source is from IMDB. IMDB listed like 24 distinct genres, but usually each movie they would have at least one or two, and at most 3 genres listed into one. So we're probably not going to get like into detail like how many of them are distinctly into each category, into each genre, meaning that one movie might have since one movie have 3 genres. Let's say, for example, right here, this film Benny and June has listed 3 genres, but for this first movie, What We Do in the Shadows, it lists only 2 of the genres. We can separate this genre into its unique values such as comedy and horror right here, but for now we're going to just group them together into like one genre. So like I said, in Benny and June here, it will be a comedy, a drama, and a romance at the same time. So for now, let's try to group this into 20 clusters, and for this we'll be using the k-means function. And we're going to like find the distance between those vectors. We can use the variables or that we have created earlier, but for now I just want to use all the movies instead of just 20 of those movies. We're going to use all the movies inside our data frame right here. And yeah, we're going to group that into 20 clusters. We're going to calculate the distance of all the movies. Sorry if I'm not being clear enough. What we're doing right here basically is to get the distance between the vectors or all the movies that we have in our data frame instead of 20 movies that we have done earlier for hierarchical clustering. And we're going to find this distance and use it as an argument to group the movies using k-means clustering. And we're going to save this inside a variable called k.means. And then let's try to have a look at the first few clusters of this k.means variable right here. So the first 10 movies listed in our data frame is our What We Do in the Shadows, Jojo Rabbit, Flipped, Benny and June, Practical Magic, In Her Shoes, What Women Want, Little Women, Untamed Heart, and Spider-Man Far From Home. Okay, so you can see that the values underneath each of these titles right here refers to the cluster that they belong into. So we see that the movies Flipped, In Her Shoes, Benny and June, and Untamed Heart, they are all in the first cluster. And if I think that these 4 movies they contain the genre of romance in them because they're practically just romantic dramas. Yeah. So now that we have figured out what clusters do the movies belong into, we're going to let's add these cluster groups into our original data. We're going to create a new data frame called movies.k-means, and this movies.k-means variable right here would be the combination of our original data, movies df right here, and also we'll be adding like a new column, which is the cluster column, the cluster element. We call this the cluster element of the k.means variable. We'll be using this cbind function right here to combine these two data and save it inside this variable called movies.k-means. And if we try to have a look at the first few rows of this new data, we can see that a new column has been added. So, okay, like if you recall that earlier I've shown this movies df data earlier, and it has all these columns, right, and these values, and now we have a new column called k.means. This $sign cluster, this is the name of the column because we specified that there will be a new vector added to this data frame, and it is the value of this variable right here. So let's rename this new cluster column by going like names, movies.k-means. So names, this names function will list the columns, all the columns that that is in our data frame. Okay, and then we're going to select the column names, where the column name is equal to k-means. The k.means $sign cluster. Basically what we're saying is that we're going to find which column in our movies.k-means data frame right here is equal to this value right here, which is this last column right here. This is how we're going to rename the columns, the k.means $sign cluster column right here. We're just going to call it cluster. So when we take a look again at the names of the columns inside our movies.k-means data frame, we see that this cluster column has been renamed. Now let's try to plot a bar chart to see the cluster, which out of the 20 clusters that we have right here, which of them has the most number of movies. We'll try to, just to look at which of them has the most number of movies grouped into that one cluster, just to see like what are the movies that are listed under that cluster, and we're going to check to see if they're of the similar genre. So I just want to include like a new column, which is the percentage of the movies, like how many percent of the movies from our original data frame is in that cluster, just for the labeling of the bar chart that we're going to do. So first we'll create an empty vector, and then we're going to use a for loop. We're going to loop across all the 20 clusters. This is to calculate the percentage of the movies, being grouped inside that particular cluster. So this round function is so that we can round this into 3 decimal places. And to calculate the percentage, we're going to get the size of the k-means function that we have created earlier, and we're going to divide it to the total number of k-means and multiply it by 100. I think this is it. Okay, hopefully it works. And we'll create a new data frame just to look at the size of each cluster using the percentage values that we have we just created. So there will be 2 columns. The first one is group, which is basically just the name of that cluster, cluster 1, cluster 2 until cluster 20, and the size or the number of movies that are located inside those each of those clusters. And now we're going to use the ggplot function to plot our data frame, the k-means size data frame. The group column will be the x-axis, and the size of those clusters will be the y-axis. And we're going to color each of those plot using the group, and we have to make sure that it is in the factor for data type. Geobar, since we're going to create a bar plot. And the rest of these are just to make our plot look clean and presentable. Okay, so this is the lines of code that we will be using to make our bar plot. Okay, so like I mentioned, we'll be using the data frame of this k-means.size data frame, and the group column will be the x-axis, the size column will be the y-axis, and each of the bars will be colored based on the group. And we'll have to put this inside a factor function right here to convert it into a factor data type, to ensure like the colors of each bar are distinct instead of like a different gradient of one color. And we'll add this geobar layer to specify that we're making a bar plot, and this theme layer is added so that we can tell that we don't want to include a legend in our plot. And this geom text layer is so that we can add labels at the top of each of those bars, meaning that I'm going to display the percentage and also the number of movies available inside each of those clusters. And this scale as discrete right here is just another layer to show to ensure that the x-axis is considered as a discrete variable. So if we run this and zoom in with our plot, okay, let's zoom this at our plot. We see that now we have there are 20 clusters. We grouped all those movies into 20 clusters, and you can see here that cluster number 7 has the most movies being grouped inside them, which is 162. This is followed by the second cluster, which has 147 movies. So let's try to take a look at what are the movies being grouped together inside this the 7th cluster and also the second cluster. Okay, and to do that, we're going to filter out. We're going to filter these movies that came in data frame, which if you recall is the data frame that contains also the cluster group of the movie as well. To filter out, first one is the 7th cluster. We can see that the 7th cluster has the most movies being grouped into them. So let's see what are those movies. We're going to look at the title and also the genre of that movie. Okay. So these are the movies that have been grouped together into the 7th cluster. And if you notice, there is like a specific pattern in our genre where the movies contain the genre of drama and romance. Drama and romance. Drama and romance. So basically the movies that are grouped under this cluster right here are considered as romance dramas, like for example this movie Titanic right here, and there's also Before Midnight, and Romeo and Juliet, Little Women, Brief Encounter, a British movie, and Atonement, also Devdas, and Jab Tak Hai Jaan, Bollywood movies as well. So yeah, we can see that the 7th cluster contains movies, romantic drama movies. What about the second cluster? If you recall, the second cluster contains the second highest number of movies located in their group. Second cluster, and we'll get the title, so then the title and the genre of them, the movies in this cluster. Okay, so these are the movies. I think you can see if I just like scroll this and at a brief glance, you can see that the word drama appears quite prominently under this cluster, and there's also like comedy and what else? They're mostly comedy, drama, and I think I noticed some sort of crime. I think there's crime, comedy, crime, drama. Yeah, comedy, crime, drama. A combination, I guess, a combination of comedy and also drama. So these are the movies that are located in the second cluster. And if you're familiar with cluster analysis, there is also the point where we want to find out what is the optimum number of clusters that we're going to group our data into. And for this, usually we'll be using the elbow plot, right, to see the optimum number of clusters. So let's try to do this right now. To get the elbow plot, the optimal value. So first, let's specify that we'll be having like we're going to have to choose the number of clusters between 1 and 24. The reason I choose 24 is because, as I mentioned earlier, the data is from IMDB, and IMDB has listed 24 distinct and unique genres. So like those genres are, like adventure, comedy, crime, drama. There are 24 of those listed from IMDB. So let's tell that we want to choose the number of clusters between 1 to 24. And we're going to calculate the within sum of squares. To plot our elbow plot right here, we're going to find the within sum of squares values for 2 to, let's say, from the number of clusters that, from the number of k's that we have. We'll be storing this inside a vector called WSS values. We'll be using this map.dbl function from the per_r package. And we'll be using like this specific function that we're going to create just to select the, to calculate the number, the within sum of squares. So for that, we'll be using this k-means function on our DTM matrix. And we're going to find the total within sum of squares. Okay. Now that we have the within sum of squares values, we're going to plot this elbow plot. So here we see the elbow plot that we have created. You can add like the title or rename the x axis and the y axis as well. We see that the elbow is located at this 9th point right here. The 8th value. Sorry, this is the 8th point right here. Since this is 10, 9, 8, so this might be the optimum number of clusters that we can group our movies into. So now we're going to restart this whole k-means clustering process using a different value for k, which is 8, that we have figured out from this elbow plot earlier. So let's just copy this function from the beginning. You know what? Let's just try to type it back again. K means 8 number of clusters. K means 8 here means we're going to use 8 number of clusters using this k means function. Once again, we're going to calculate the distance between the matrix, between the documents inside our documenter matrix right here, and we'll group them into 8 clusters. And we're going to bind our original data frame with the cluster groups that we have calculated, that we have figured out earlier from this k-means 8 function, k-means 8 variable. Right. Movies df k-means 8 cluster, and then we're renaming the cluster column. find the percentage using this similar one from earlier. I'm just going to copy this one. And instead of 1 until 20, we're going to stop at 8 since we have 8 clusters. And okay, renaming this to K means 8, K means 8. Okay, I think it's probably going to work like that. Creating a new data frame. And plot this new data frame. Similar to what we've done earlier, we're going to create a bar plot. So basically it's just the same plot. Okay, so it's just the same plot that we have created earlier. And okay, let's change this to, sorry, I forgot to add this one. K means per 8, K means the percent 8, and K means size 8. I think that's working. Alright. Okay, so this is like this is the new plot of the plot of the new clustering that we just made. We've regrouped. We have regrouped our list of movies into 8 clusters, and we see that the 8th cluster contains the most number of movies, followed by the second cluster. So let's try to take a look at the movies. Let's try to take a look at the movies in like the list number of clusters. This one is 6, so the 6th cluster has the least amount of movies, so we'll try to look at the movies listed under this cluster right here. Okay, okay, so these are the movies that are in the 6th cluster, and if we take a look at this, I don't think I can see like any specific pattern, like any distinct pattern, just as we did earlier. Like the movies listed under this cluster are quite random, don't you think? Like, you know, this film Dreamgirls is a musical, a drama musical, and then there's Strangers on a Train. Isn't this film a Hitchcock film? It's a thriller, right? Yeah, it is a crime and a thriller. These two movies, I don't think these two movies are similar at all. And I think, as for, you know, like this movie, this is a documentary, George Harrison Living in the Material World, Tina, and Dear Zachary. These are documentaries, so I think I can see like the similarity of putting them into one cluster, as well as this one Cropsey right here, Bombshell, and For the Love of Spock, Fire. These are all documentaries. I guess we can say like the distinct similarity between all these movies, not all of them, but most of them would be there under the documentary genre. So I guess that's all for clustering analysis. So basically, this is the end of this project. If you have any questions or there are parts that you don't understand, feel free to drop them in the comment section below. If you enjoyed this video or you might have learned something new from this, Please give this video a thumbs up and subscribe to my channel for more contents like this in the future. Thanks for watching.